Okay, in this video we're going to be graphing square root and cube root functions. Let's talk about, remind you of the parent function of a square root graph. F of x is equal to the square root of x. Let's plot some points and look and see what that, remind you about what that graph looks like. Some points on that graph: the square root of 0 is 0, the square root of 1 is 1, the square root of 1, 2, 3, 4 is 2, and the square root of 9, 6, 7, 8, 9 is 3. Connect those dots, and you see the basic square root function, which is a sideways parabola, half of a sideways parabola. Endpoint, or the starting point of your graph, is going to be right here at 0, 0. The domain, you cannot take the square root of a negative, so therefore the domain is going to be all values from 0, including 0, because 0, 0 is on your graph up to infinity. Your range, notice that there's nothing down here, so your range is also all values from 0 and up. Next up, your cube root function. Parent function is f of x equals the cube root of x. Let's plug in some values. I know the cube root of 0 is 0. The cube root of 1 is 1. The cube root of 8 is 2. We can find the cube root of negatives. Cube root of negative 1 is negative 1. The cube root of negative 8 is negative 2. So we connect our dots. Our cube root function looks something like this. There we go. The turning point, okay, would be this point right here in the middle. We have a turning point at 0, 0, where it changes from negative to positive there. Our domain of this function, domain would be all real values because it goes left and right forever, and we can take the cube root of anything we want to. The range values as well go from negative to positive infinity, go up and down forever. Now let's transform this. Let's remind you about the transformations. Here is all the transformations that we're going to be talking about. The minus h inside with the x. Remember that if it's on the x, it's going to be moving it right and left. So a minus h, since it's minus, would actually shift it to the right h. So h is the horizontal shift. And again, if it's a minus, it'll shift it right. If it's a negative, it's going to shift it left. So let's put a plus shifts it left. A minus shifts it right. And then the plus k on the end. K is the vertical shift. If it's a positive, it shifts it up, and if it's a negative, it shifts it down, just like it says it's going to. The endpoint or the turning point, therefore, would be transformed. So in this case, if we move it right h and up k, it'd be transformed to hk. That's going to be the starting point of your graph. If A is a negative, now let's talk about your stretches and compressions and flips out here. If A is a negative, that's going to be, since it's out here, it's going to be vertical. If A is a negative, it's the function is going to be flipped vertically, so that'd be across the x-axis, up and down. If the absolute value of A is greater than 1, so therefore, if we have a value here bigger than 1, then that's going to represent a vertical stretch. And if it's smaller than 1 or between 0 and 1, that's going to be a compression of the graph. So let's go through all these transformations with actual problems. Describe the transformations compared to the parent function. So let's zoom in here. Again, let's work all of our stretches, compressions first. There's not any, there's no flips, but there is a couple of translations. This minus 7 would be a translation right 7 because it's always opposite since it's on the inside, and the positive 2 would be up 2 units. And so it's your parent function moved right 7 and up 2, and that's it. This one, there's nothing inside with the x. However, there is a stretch out here. This is going to be, it's going to stretch your graph vertically because it's on the outside times exactly what it is, times a 4. So therefore, that's going to be a vertical stretch by a factor of 4. And the only other thing that you have is this minus 1, which will move your graph down 1 unit. Number 3. There is a negative on the outside. Since that negative and there's no multiplication, so we're done with stretches, compressions already. Since there's a negative on the outside, that's going to flip your graph vertically across the x-axis. And then the last thing that's going to happen is your graph is going to get shifted. Since it's a plus 3, it's going to get shifted left 3 units. And I do want to point out here that your parent function on this one is actually the cube root of x graph. Number 4, and I believe number 2 is also a cube root of x. If we had to identify, do we need to, let's see, I don't think we're having to identify the parent function. But number 4, all stretches compressions first, so this 1/2 is being multiplied by the entire function, so therefore that would be a vertical, since it's 1/2, that's smaller than 1, that'd be a vertical compression by a factor of 1/2. And then there's no negatives, but you do have some minuses here and here. The -2 that's on the inside with the x is going to move your graph right 2 units. And then the -6 at the end is going to move your graph down 6 units. Next section says, number 5, the square root function or parent function is reflected across the x-axis. Then it's shifted 7 units left, 1 unit down, write the equation. So it's a square root function. Okay, first off, it's reflected across the x-axis. So therefore, my function is now, what used to be square root of x is now the negative square root of x. That's going to reflect it vertically. It's going to be shifted 7 units to the left. To shift it left, we're going to do a +7. It's opposite of what you would think. So 7 units left, and then 1 unit down would be a -1 on the outside of the function. The cube root function is your parent function on this next one. The cube root of x has a turning point at -2, 3. So what does that mean? It means it's been shifted left. It used to be at 0, 0. However, it's been shifted left 2 and up 3. So my new function, let's shift it left 2, so that's going to be an x plus 2. And then we're going to shift it up 3, so we're going to add a 3 on it. Write an equation that could represent this function. That is your new function. Okay, starting on number 7, it says graph each radical function, identify the key characteristics. So what I'm going to do, just to get used to transformations, I'm going to take and I'm going to graph my parent function. And then I'm going to take the points on this parent function and I'm going to show you the shift that they're going to go through. So here's my parent function, the square root of x. However, this graph has been moved up 5 units. So I've written down 3 points that's on my original graph, and I'm going to take each of those points, and to move them up 5 units, I'm only going to be changing my y value here. So I'm going to be moving it up 5, so that'd be 4, 7. So there's my new points. Now let's plot those. And there's a picture of your new graph. Your domain for your new graph, notice there's no graph over here. Your domain does not change. It still goes from 0 to infinity. We did not move it left or right any. The range, however, used to be from 0 to infinity. It has now been moved up 5 units and it is now 5 to infinity. Notice there's no graph below 5. Your endpoint or your turning point, which used to be at 0, 0, got moved up 5, so it is now located at 0, 5. Your end behavior, let me erase this so I don't get it confused with it. As x goes to the right, your y value increases. As x approaches, now the left side does not approach negative infinity, it approaches 0. And as x approaches 0, then your y value approaches 5. Your increasing intervals, it increases over the course of the entire function. It starts at 0 and it increases forever. And decreasing, there is no points of decreasing on this graph. Your next graph, do the same thing. Let's graph the parent function, identify some points on that parent function. We have 2 different transformations. We're going to take our points, we're going to move them right 1 and down 4. So right 1, down 4, that's our only transformation. So let's take our first point and let's move it right 1. So just take your x value, move it right 1. Move your y value down 4, so it is now at -4. 1, 1, right 1 will be a 2, down 4 would be a -3. 4, 2, right 1 would be a 5, and down 4 would be a -2. Now let's plot these new points. And here's your new graph. Your domain now starts at 1 and goes to infinity. Your range is negative. It starts here at -4 and goes up to infinity. Your endpoint or turning point got moved. Again, here's the endpoint or turning point. Got moved right 1 and down 4, so it is now at 1, -4. The end behavior, as x goes to the right, your graph goes up. As x goes to the left, it approaches here this positive 1 value. So as x approaches positive 1, your y value approaches negative 4. Your graph is increasing everywhere. It starts here at positive 1, and it starts increasing, and it increases forever. So your increasing interval will be 1 to infinity, and your graph never decreases, so you will not have a decreasing interval. The next one, you have two different transformations. You have a vertical shift, or excuse me, a vertical stretch by a factor of 3, and then your graph gets shifted left 1 unit. So let's jot those down. And let's also, again, sketch out our parent function, which would be, in this case, y equals the square root of x, and jot down a few points on that parent function. So now let's apply all of our transformations. And again, what we're going to do, we're going to stretch out our y values times 3, and we're going to move all of our x values left 1. So move your x value left 1 and multiply your y value by 3. Again, move your x value left 1 and multiply your y value by 3. Move your x value left 1 and multiply your y value by 3. So here's my 3 new points. Let's plot them and see what it looks like. Okay, there's our new function. My domain now starts at negative 1 and goes right. Your range, your y value starts at 0 and goes up. The turning point or the end point, the only thing that happened with it, it got stretched, which didn't change it. It only got moved left 1, so it is now at negative 1, 0. In behavior, as you go to the right on your graph goes up. And the other end, as you approach negative 1, as your x value approaches negative 1, your y value approaches 0. Again, this graph is always increasing, so it's increasing from negative infinity, or excuse me, from negative 1 up to infinity, because it starts here and then increases to the right, and it never decreases. Next problem. Parent function again is root x. Let's graph it. Now let's identify all of our transformations. Stretches, compressions, there are none. Now let's look at our flips. There's a negative on the outside, so that's going to flip it vertically across the x-axis. Then your other two transformations, you have translations. That's going to move your graph right 2, and it's going to move your graph up 3. So now let's apply those transformations. And I do want to remind you, a vertical flip changes a point from up here to down here. So what it's going to do is going to change your y value. It'll change, if it was a positive 2, now it's a negative 2. So let's do all those first. Your vertical flip will not do anything to your first point. Your second point will now be 1, negative 1. Your third point will now be 4, negative 2. That's your vertical flip. Now let's apply your translations. Right 2 will change all of your x values to the right 2. So add 2, and add 2. To move it up 3, you're going to change all your y values by adding 3. So plus 3, and plus 3. Let's graph these new points and see what our function looks like. So here's a look at it, and you can see that it got flipped, and then after it got flipped, it got moved right 2 and up 3. My domain now starts here. So that'd be from 2 to infinity. My range values are here and down. So that'd be, you always count range from bottom up. So that's going to be from everywhere from negative infinity up to that y value of 3. My turning point, again, was at 0, 0, and it's now here at 2, 3. In behavior, as we travel to the right on my graph is increasing, or excuse me, decreasing. It's going downhill to negative infinity. As we travel to the left, my x value approaches negative 2. And as I approach negative 2 on my x, my y value approaches 3. My function is never, you always read increasing and decreasing from left to right. It's never increasing. It's always going downhill. So nowhere is it increasing, but it's decreasing from 2 forever. So that would be from 2 to infinity. Your next graph is a cube root graph. So let's go ahead and graph our parent function of the cube root. And there's my graph and a few points that's on my graph. Now look at all of our transformations, and all we have is a translation. That plus 3 is going to move your graph left 3 units. That plus 2 is going to move your graph up 2 units. So let's take all of our x values and move them left 3. And take all your y values and add 2 to them, move them up 2. And there's all your new points. Now let's take and plot those points and see how my graph changed. And there's your new graph. And notice it's pretty much, we knew it would be, it's the same graph that's just been moved left 3 and up 2. Your domain is still an infinite, negative to positive infinity. Your range is still the exact same thing, negative to positive infinity. Your turning point, which used to be at 0, 0, got moved again left 3 and up 2, so it is now at negative 3, 2. As you travel to the right on your x-axis, your graph goes up. As you travel to the left, your graph goes down. Your increasing interval, it starts increasing at that turning point, and it increases from, that x value would be negative 3. It increases from negative 3 to infinity, and it decreases from, well, actually, hang on. It actually always increases. You read these from left to right, so it's going uphill, and it continues going uphill. So it actually increases from negative infinity all the way to positive infinity, and there is nowhere that it's decreasing. Next problem. Number 12, again, your parent function is cube root of x, so let's graph it. And there is your graph and the points that are on the graph. Now let's identify our two transformations. Let's do all of our stretches and compressions first. Since you've got the 2 there, that's going to be a vertical stretch by a factor of 2. And I just called that, again, a y stretch because that is vertical, would be a y. And then you have a negative out front, which would be a vertical flip, or an up and down flip. That'd be a flip across the x-axis. So now let's apply all these transformations. So we're going to multiply our y's times 2, and then we're going to flip it across the x-axis by making them negative or positive. We're going to change their signs. We can do all that in one step. So we're going to multiply, our x values are going to stay the same. Our y values are times 2, and then make them the opposite. So negative 6, make it positive 6. Negative 1, multiply it by 2, gives you negative 2, and then make it the opposite. Multiply the y value by 2, and then make the opposite, does not change it. The next one, multiply your y value by 2 and make it opposite, becomes negative 2. Multiply your y value by 2 and make it opposite, gives you 8, negative 6. And here's a picture of your new function. Domain and range still negative to positive infinity on both. Goes up and down forever, left and right forever. The endpoint of the turning point did not get moved at all. As we go to the right on our graph, my graph goes down now. As we go to the left, my graph goes up. And the reason for that is because of the vertical flip. Your increasing interval, there is not one now, because from the left all the way to the right, your graph is going downhill. So it's decreasing everywhere, negative infinity up to positive infinity. Number 13. Your parent function here is, again, y equals the cube root of x. So let's go ahead and graph that and write down our points. And there those are. Now let's identify all of our transformations. Stretches, compressions. This is going to be a vertical compression because it's less than 1, a vertical compression by a factor of 1/2. And then the only other two transformations is the plus 1 is going to move it left 1, the minus 5 is going to move it down 5. So we're going to move it left 1 and down 5. So let's go through first off and multiply by all of our y values by a factor of 1/2. And now we're going to move all of our x values left 1. So that's going to subtract 1 from all of our x values. And then all my y values will be moved down 5, which again will subtract 5 from all my y values. And there's a list of all of our new points. Now let's take each of these points and let's plot them and see what they now look like. And I'd actually messed up on 2 or 3 of my points there, so make sure you fix those. But again, here's my new graph that's been shifted left 1, down 5. And it's now a half as tall as what it used to be. So it kind of pressed it out, made it a little bit skinnier, not quite so tall. My domain and range. Domain is negative to positive infinity, and so is my range. It still goes up, down, left, and right forever. My endpoint, my turning point used to be at 0, 0. It is now moved. Let's see, we moved it from 0, 0 to right here now at negative 1, negative 5. As we move to the right on my graph, we are still increasing. As we move to the left on my graph, we again are still decreasing. Where's my function increasing from left to right? It is going uphill forever. So that'd be left to right. We're going from negative to positive infinity, increasing, and my function is never decreasing.